Jean-Baptiste. Allez.
It's all the French.
All the students from the last row. Okay, thank you. The next talk is from Bryan about Open Services Cloud. So as you have the microphone, Bryan, I'll let you start.
Okay. So thanks a lot. So welcome back from the coffee break. So before I joined Huawei, I spent 15 years at Red Hat, and we used to have a CEO, Bob Young, back in the very early days of open source, and he would use an analogy just to explain to people what was open source back in the day. And he would ask people, would you buy a car with the hood welded shut? And then people would say no, and then he would say, well, then why would you buy software where you can't see the source code? And it was a very useful analogy for explaining the value of open source, and I still hear people refer to it today. But I think with the rise of cloud, starting with AWS and with what we have today, we have to ask a very different kind of question, especially when it comes to open source and what we think about cloud, because it's no longer people purchasing software that they run in their own computers. Now with the cloud, people will typically rent it as a service. And so if you really wanted to take the question forward, we'd have to ask something like, would you order an Uber or a Didi car with the hood whittled shut? And a lot of people would still say, no, actually, no, I prefer that, the car I can see inside. And so we saw a lot of very popular open source projects related to cloud, like Kubernetes and OpenStack and so on. But I think the question has really shifted even more in recent years, because if you take a look at the most popular services that are run across clouds today, they're all much higher level managed services, whether the AI services like we've been talking about, or database, or message queues, and so on. And most enterprises have no capability to run these kinds of services in their own data center. So the question is really something like, would you order a self-driving, personalized entertainment providing turbo boosting car built, owned, and operated entirely by Uber or Didi with the hood welded shut? And at this point, pretty much everyone would just say, no, I'll take it any way I can get it, because it's the only way I can get it, whether it's open or not. So in order to, I think, address a lot of the big issues that we're facing in the industry, we need to ask a different question, which is, do you want to live in a world where only Uber and Didi can offer you transportation services? Or just to be very explicit about it, do you want to live in a world where fewer than 10 clouds can offer you all the digital services, because this is the current path that we're headed on, and I think it's what's driving a lot of the issues and questions that we've been talking through throughout the workshop today. So what I want to do in the rest of today is just to start to explore with you something that we've been working on and partnering with the Eclipse Foundation to bring forward into open source, where we think that there's a different way in terms of how do we need to start thinking about what does it mean to be open from a cloud perspective. Now, in order to explain our thinking around this, I want to use the analogy of a smartphone throughout this presentation. And in particular, if we think back to when the iPhone first launched back in 2007, there was no app store yet. In fact, the only apps that you could run on the iPhone were the ones that Apple installed themselves. Everything else had to run as a web app in the Safari web browser. This is an actual ad from Apple in 2007. So it says, flick through movie times, tap on a train route, scroll through sports scores, web apps and multi-touch make it possible. And the reason I use this is very much the same situation that we have with clouds today. When you take a look at clouds today, we're all consuming managed services across these public clouds, but the only one who can actually run and operate and provide managed services in the clouds are the cloud service providers themselves. Everyone else in the ecosystem, if you're a software vendor, if you're a hardware vendor, you're pretty much reduced to the equivalent of offering web apps in a web browser. Let me show what I mean by that. When you look at clouds today, there's two primary ways if you're a software vendor or an ecosystem vendor to get your solutions into a public cloud. The first is what we see here on the left. This is the most popular option, which is that you upload your software as an image into a service catalog. And so here, I've just shown some of the more popular ones that you can find in software image marketplaces like MongoDB or Red Hat OpenShift or SAP and so on. The challenge with these software images is that the customer is responsible for, I have to configure it, I have to operate it, I have to secure it, I have to manage it, and so on. On the other hand, the service providers offer competing managed services. So for example, Azure Cosmos DB against MongoDB. Here in Huawei Cloud, we have our own container service. Amazon Redshift, against SAP. These are managed services, and basically they're just point and click for the customer. They don't have to do any of the operational things that you have to do with these software images. So there's a huge advantage, to consuming the managed service from an operational standpoint compared to the software image. So on the right, this is how a lot of the software vendors have been trying to address this problem, is that they create software as a service versions of their solutions. So we have, for example, SAP Cloud Platform or OpenShift.io, MongoDB Atlas, Confluent Cloud with Apache Kafka, and so on. The challenge is that even when we create a software as a service version of these software, they are still highly inferior compared to the managed service offerings that are native to the cloud providers. For example, each of these 4 SaaS offerings are all available on the same physical infrastructure in the same data center, for example, in AWS. On the other hand, if I want to go ahead and as an enterprise customer consume and create applications across these, I have to go to 4 different websites. I have to deal with 4 different identity systems. I have to deal with 4 different billing systems. I have to deal with 4 different data and networking systems. Even though they're running on the same physical infrastructure because they're isolated as silos from a software as a service standpoint. On the other hand, if I use the AWS equivalent of all these, I don't have any of these limitations. 1 identity, 1 billing, 1 deployment, 1 data space, 1 network space, and so on. And so I would argue that the ecosystem is fundamentally locked out from being able to create managed services in the clouds. And this is one of the big problems that we have in the industry. Why do we have so much incumbent power in the cloud providers? One is because they are the only ones who can create the actual services that are very rich from a cloud provider perspective. So that's the first problem, which is basically industry lockout when it comes to these clouds. Now, the way that a lot of people are trying to address this from a customer and from an enterprise standpoint is that everyone is adopting a multi-cloud strategy. The problem with going multi-cloud is that I would argue multi-cloud today is just like multi-phone back in 2007. Again, going back to my smartphone analogy, I'm originally from the US. So I just went and searched on the web for, back in 2007, 2008, how would you, transfer your contact data from one phone to your shiny new iPhone? Step 1 in the instructions were, go to an AT&T store. Step 2 was use their proprietary software to download your contacts from your phone into a proprietary format and then upload it into the new phone. And that's sort of the state we have today. Forget your games, forget your notes, forget your data and other things. You're forced into this very primitive capability in terms of how do you get your data from one device to another. So same thing's happening from a cloud standpoint if you go multi-cloud. This is just a picture I took of just the compute services available at AWS, at Huawei Cloud, and at Azure. And basically, if you look at just the compute services, there's 2 services we have in common here. One is virtual machines. The second is Kubernetes. If I go to AWS and I use Lambda, I'm still locked into AWS. If I go to Huawei Cloud and I use an FPGA server, I'm basically tied in there. If I go to Azure and I use Azure Batch AI, I can't go anywhere else because these services only exist in these clouds. So if I really want to go multi-cloud, I've got to go either least common denominator and lose a lot of the advantage of going to cloud in the first place, or I've got to richly tie myself just to 1 or 2 clouds and split my applications. Neither is ideal in what enterprises are looking to do. And a lot of people are thinking, we just need to use more and more open source software to solve this issue, especially when it comes to login. But I would argue that this is actually a problem that open source fundamentally cannot solve. So to explain that, I'm going to use 2 very popular open source projects to explain what happens between a software standpoint and a service standpoint. On the left, probably the most popular open source project of all, Linux. So what happens is you have the community, we can come together, we can all create the Linux kernel, the Linux operating system. We have a bunch of community distributions out there, whether it's Ubuntu or Fedora, SUSE, Debian, and so on. Anyone can download Linux, anyone can use Linux as they want. And then there's a whole bunch of different commercial options if you want to go into production with Linux. Kubernetes, arguably the most popular open source cloud project. Huge community behind it. But there's no such thing as a community distribution of a managed service. The first time I can consume Kubernetes as a managed service is when one of the service providers installs it into the cloud and operates it for me. Otherwise, I'm back in that old world I spoke about. I either have a software image or I have a software as a service. I don't have a managed service in a cloud. And so I've got to wait for Google or Azure or Amazon to put it in. And by the way, typically when you go into these clouds, they've tied it in with other proprietary services and added proprietary APIs on them. So they created a point of lock-in, and they're also picking the winners and losers because, just as a side note, some of you will remember that Amazon was actually trying to fight against Kubernetes for 2-3 years after Kubernetes first came out into open source. They were the lone holdout in terms of not making Kubernetes available because they had their competing scheduling technology. And so the cloud providers are trying to pick which open source project can you get as a managed service, which one can you not get as a managed service. The rest of the ecosystem, the open source community certainly has no control over what are the cloud providers going to put in their clouds and take away from their clouds. So this is a big problem from an open source standpoint. There's a lot of discussions throughout today, and also in Europe around cloud data. I would argue that cloud data is the ultimate lockout and lock-in example. So just to show what I mean by this, from a lockout standpoint, there are a lot of software vendors and data storage solution vendors here in Europe and around the world, but you don't find them available in public clouds. The reason for that is that they are locked out from being able to run efficient infrastructure and from being available as a managed service. So if I wanted to go and run one of these software-defined storage solutions, I would have to go and rent my infrastructure. I'd have to tie it into run it as a standalone service maybe, but it's not going to provide data backing for any of the first-party services in the cloud. So I'm dealing with a split world from a data standpoint. If I use, for example, Google Cloud Storage, I don't have any of those limitations. From a lock-in standpoint, a lot of people think, I've got to get data portability. Data portability is hugely important, but it's not sufficient if we really want to solve what we're doing, because most data in the cloud is tied in with a particular service that is not portable. So even if I could take all my data out of Azure Cognitive Search and move it into Google or into OVH or into Scaleway, for example, doesn't do me any good because Azure Cognitive Search service is not available in any other cloud. If I took all my data out of Amazon Redshift and I moved it into another cloud, whether Oracle or Huawei or whomever, doesn't do me any good because Amazon Redshift is not available in these other clouds. So the fact that my data is coupled with the service and my services are not portable means that no matter what I can do with my data, until I can process it where I want, we're still dealing with a big issue around data lock-in and data lockout. So the way that I think we need to start to address this problem is we need to create a new marketplace for how do we have open services from a cloud standpoint. So going back to my smartphone analogy, as I showed, back in 2007, the iPhone was a closed device because there were no third-party applications at the time. But of course, that's not the situation we have today. Today, we do have app stores. I can install a third-party application, on an iPhone, on an Android phone, or whatever, and it's largely similar to the first-party applications. It's very easy for me to switch device manufacturers today from one manufacturer to another because my apps are available across different devices and my data can move with the apps, especially with a lot of cloud services and so on. And so this is the same dynamic that we want to create from a cloud standpoint. So if we're going to do that, we've got to address the lockout problem and the lock-in problem that I was talking about. So how do we aim to do that? What we aim to do is with this project, I call Open Services Cloud. The reason I call it Open Services Cloud is that we want to open up the services layer inside cloud platforms, just as we've opened up the source code layer inside of open source software. So let's do that by solving first the lockout problem, and then we'll start with the lock-in problem. Let me first start from a lockout standpoint. Down here, this is just a high-level picture, of a cloud, and this XS cloud service in the yellow. This is any of the accessible services that you would have in a cloud. This could be a database service, it could be an AI service, it could be a container service, or what have you. Within every single public cloud, there are these internal services that cloud providers use to operationally turn their software into a managed service. And so, for example, we have things like console access, authentication, billing, deployment, monitoring, and so on. Every single cloud provider has these. Every single cloud provider keeps these private to themselves. No one else can access these. And this is sort of the secret sauce that we as cloud providers use to turn our software into a managed service. So the first thing that we're working on across our cloud and our customers and with our partners is that we are opening up access to this layer across our clouds. So if you come into our clouds at Huawei and partners and so on, you will be able to create a managed service as a third party into our cloud, no different from how we can create a service in our own cloud. First time this layer in the cloud will be opened up for third parties to be able to come in and create managed services. But this creates another point of lock-in because every single cloud has a different way of how they implement, just identity, for example. So the second thing we need to do is we need to standardize and we need to open source. How do we actually access these kinds of services? So we're creating an open source framework for Open Services Cloud. And this open source framework will do several things. The first thing that we will do is we will define together what is the minimal set of services that a cloud provider must expose in order to turn software into a managed service. And the second thing we will do is we will provide an open source implementation of what are those minimal set of services that a cloud provider must provide. Just by way of example, at Huawei, we happen to have 10 of what we call these service enablement frameworks. So it's not a huge set, but they're critically important. The third thing that we will do is that we will provide a mapping of these standardized open source APIs into underlying cloud providers' different service engine implementations. So we could map it into Huawei Cloud, we could map it into Flexible Engine or Open Telecom Cloud, and so on. What that would allow us to do now is to create real open portable services across a multi-cloud. Because a software vendor like SAP could write once against this Open Services Cloud framework, and then they would be able to deploy it as a portable, live, managed service from one cloud to another. First time that we would be able to create a real service marketplace that could go across multi-clouds, and that would allow customers to be able to choose what is the cloud provider of my choice, what is the service of my choice. And it opens up the opportunity for the entire marketplace around services to go beyond just from what can I get at Amazon, what can I get at Microsoft, what can I get at Google. We think that this actually provides a very nice mapping into a lot of the Gaia-X requirements. So one of the reasons that we have been working and are targeting to open source this at Eclipse Foundation is, Eclipse Foundation is also a member of Gaia-X. They're very strong in Europe, but they have global influence. So for us, we would be doing this, whether or not there were Gaia-X, just because we think this is a fundamental problem in the industry. But as we started to look at Gaia-X, and one of the reasons that we joined as a member is because we saw a lot of synergy between what they were trying to do and what we've been trying to do with our Open Services Cloud initiative. So just to show you as an example of what we would envision, this would look like, from an implementation standpoint. If we wanted to, really enable decentralized, federated services, whether in Gaia-X or whether, in the broader industry, what we would be able to do with Open Services Cloud is, we'd have a whole bunch of different clouds all running this, Open Services Cloud, framework, exposing their service, APIs. On top of that, you could have first-party services and you could have third-party services. And then, whoever wanted to create a catalog, we don't define who that is, but it is possible now to create a decentralized catalog that says, I consume SAP from here, I consume a Bosch service here, I consume a first-party Kubernetes service from here, and then I can switch my providers, transparently, because my services now are uniformly available across different clouds, and I can federate them, however I want. And so we think that this is a nice approach for how do you actually get to a decentralized service, with portability and choice across providers and services. Now, I want to show just a little bit more in detail, how we are planning to implement this with our own cloud. Just so that you have a better picture of what this looks like from an implementation standpoint. This is a exploded, more detailed picture of what I showed you when I first introduced Open Services Cloud. But this yellow box again, is any of these publicly exposed services. This could be a database, container service, AI service, or whatever. Within our cloud, we, as I mentioned before, have these 10 service enablement frameworks for how do we turn software into a managed service across our cloud. And so our first-party services, so for example, Model Arts for AI or GaussDB or a Cloud Container Instance, this is how we write to these APIs and turn these into managed services in Huawei Cloud. So what we will do is we will implement this Open Services Cloud framework, and we will run this in our cloud. And so here we will identify, what are the standardized services, cloud providers must expose to turn software into managed services. So things like billing, deployment, logging, console access, identity, metrics, API gateway. And then we are planning to deploy a third-party service zone within our data centers. So then third parties, such I'm just using examples here, Bosch or SAP or Atos or Siemens, they can come, they can just access these service enablement frameworks within our cloud, and then they can become services in our service catalog, no different from the first-party services. So this is where I'm showing, we've got a unified service catalog now. So if you want to use a Huawei service, if you want to use a SAP service, if you want to use a Siemens service, there's no differentiation in functionality or from a customer standpoint, how they consume them across the cloud. And so this is the work that we are doing and how we are driving from an implementation from our own cloud standpoint. And I've highlighted here just that we're working with the Eclipse Foundation across this open source initiative. So, based on this, we really think that there's an opportunity to start to transform clouds from basically what is a closed platform today into an open market from an ecosystem standpoint. So if I just look at these different dimensions, today, my service catalog and my marketplace is sort of split between software images and software as a service islands for third parties versus first-party services. And so with Open Services Cloud, we can just get everything as a managed service, no differentiation first party or third party. Today, ecosystem is locked out, customers are locked in, data, as I mentioned before, is the ultimate lockout, lock-in example. We can turn that to, in the ecosystem, now we're partners together. Every cloud provider, every vendor can come in and we just create a much larger ecosystem together. Customers are not locked in because we've introduced real service portability for the first time into the industry. So, coming back to my smartphone example, again, just as I get ready to wrap up, I want to show one of the things that happened from a smartphone standpoint that was really interesting was this is taking a look at the market size of both the phones, but also of the ecosystem from an accessories and from a mobile application standpoint, and what happened over the last 13 years as the mobile phone market exploded. Back in 2007, the ecosystem market size was about $32 billion US. This was all phone accessories. Of course, there was no application revenue back then. In 2020, the accessory market for phones blew up to $221 billion US. The application, a mobile app market exploded to $582 billion. And so very, very meaningful growth in the ecosystem size, along with the overall smartphone growth. Today, all cloud services are owned just by the cloud service operators. So we're starting from way back here, but we think we can create a new market for cloud services that follows the same pattern. And that's our goal from what we're trying to achieve from an industry standpoint. We want to create a new marketplace for real cloud services and give the opportunity for them to grow across these open marketplaces. And we think that this is a real win-win from a cloud provider, from a software provider, and also from a customer standpoint. We're a cloud provider ourselves. We're a consumer of cloud services, and we also have software. So we ourselves as a company fit across all three, and we see benefits for all three use cases. I'm just going to show what's the current situation and where we see some of the pain points evolving, and how Open Services Cloud can start to normalize this from an industry standpoint. So here today, this is any sort of public cloud, and we have a mix, as I mentioned before, between first-party services, could be an infrastructure service like a virtual machine, and then we have native, higher-level managed services, for example, an AI service or a database service. Now, one of the issues that we have today is that the cloud providers actually compete with the software vendors that run across their cloud. Let me just use OpenShift as an example, my old company. So today, OpenShift, when a customer deploys that on a cloud provider, they drive a lot of infrastructure usage. That's good for the cloud provider. On the other hand, if I run my application on top of OpenShift, it is very hard for the cloud provider to upsell any of the other managed services. Because, for example, if I upsell an AI service, these don't integrate with this, because now I'm dealing with different billing systems, identity systems, data systems, as I mentioned before, because this is basically an island. It's a silo on top of the cloud. And so Red Hat, and the customer, well, Red Hat is incentivized to say, don't purchase the cloud services, just run more and more as container images on top of OpenShift. So now the vendor is competing with the cloud provider in terms of where's the customer going to run the workloads, and the customer has to make an artificial choice. Maybe I would actually prefer this database service, but from an operational standpoint, it's easier for me to go here. Or maybe I start off with the database service, and now it's harder for me to go to OpenShift. I don't have that ability to freely choose what I want to. With Open Services Cloud, where we can turn everything into a native service, the cloud providers and their ecosystem are no longer competing in a zero-sum game. Either you're our customer or you're their customer. We can share all the services between us. And then from a customer standpoint, this is much, much better for them, because now they really get to choose. Maybe I use this software provider, maybe I use this first-party service, but it's all the same to me, and I run it in the provider of my choice. So this is where we're trying to push the industry towards, and where we think that we can end up with a much better state in terms of how things happen. And so this is why we really believe that this is something where, whether you're a cloud service provider, you're in the industry, you're an ISV, you're an end user, moving towards this model highly aligns the industry towards something that is just significantly better for everyone involved. And so what we're hoping to do, in terms of introducing this at the AICE Open Lab Working Group, but also beyond, is that we're looking for other vendors and partners and customers and end users, anyone who wants to contribute towards creating this more open ecosystem for cloud services, to join us here in the Eclipse Foundation. We're in the process of setting up a new working group and set up open source projects around this. And we will also be bringing this into the AICE Open Lab as a special interest group, so that we can test and implement the interoperability using the AICE Open Lab infrastructure. So that's it, and hope to see you guys in this project. Thank you.
So the next presentation will be on a remote one. So as we get as they start sharing, we have a question from Marcel from Red Hat, as you can guess. He says, is there a link to the code that powers the Open Services Cloud? Where to find out more? So it looks like he may be interested in participating.
So we are in the process of going through the contribution to Eclipse, so it's not there yet, but happy to have a discussion with you, separately if you want to discuss more in terms of what's there right now.